Intermediate Algebra for Statistics, Section 2.6, Part 2. We will begin with this slide. Division by zero is not allowed. It is what we call undefined. A real number can never have a denominator of 0. Let's do an example. If I take 0 divided by 6, the result is 0. It's a real number. If I take 6 and divide it by 0, the calculator states that there's an error because this is undefined. It is not a real number. Example 4. Evaluate the quantity a minus b divided by the quantity c minus d when a is 4, b is negative 2, c is negative 5, and d is 4. So the first thing that we do is substitute the numbers in for the variables. We have 4 minus negative 2, all being divided by negative 5 minus 4. So if we take 4 minus negative 2, that becomes a positive 6. Because when you're subtracting a negative number, you add. And negative 5 minus 4 is negative 9. Now this is a fraction that can be reduced. And also a positive divided by a negative is a negative number. So it's good math manners to write the negative sign in front of the fraction. And then if we reduce 6 over 9, we get 2/3. So our final answer is a negative 2/3. Using the TI 8384 calculator, we would have to include parentheses for both the numerator and the denominator, because we want to compute this first, compute this next, then divide these two. The calculator output is negative 0.666. Then it rounds off here. If we want to write that as a fraction, if you recall, we hit the math key, then hit enter for fraction, and it will take the answer and change it to a fraction. Example 5. Evaluate 4x squared for x equals negative 3. Number 2. Evaluate b squared minus 4ac when a is 5, b is negative 3, and c is negative 6. We will see this expression later on in the course when we get into quadratics. So number 1, we substitute in negative 3 for x. Our next step is to square. Negative 3 times negative 3 is positive 9. Then multiply that by 4, and we see the result is 36. Number 2, substituting in negative 3 for b, 5 for a, and negative 6 for c. We have to compute this. So the first thing that we do is square. We get positive 9. Next, we're going to multiply. So 4 times 5 is 20. 20 times negative 6 is a negative 120. Of course, subtracting a negative number means you add. So our final result is 129. Example 6. Let x be a number. Translate the phrase 6 minus the product of negative 5 and a number into a mathematical expression. Then evaluate the expression for x equals negative 3. So the first thing that we do is translate the phrase into an expression. 6 minus means we're going to subtract. Product means we multiply. We're multiplying negative 5 and a number, which we call x. Now we want to evaluate when x is negative 3. So we substitute in negative 3 for the expression and perform the operations. So the first thing that we're going to do is multiply these two. Negative 5 times negative 3 is positive 15. So now we have 6 minus 15, which is negative 9. In this example, what step do we do first to evaluate if x is equal to a negative 3? We would take negative 3 and subtract 1. We have to do parentheses first. The second step, once we do that, negative 3 minus 1 is negative 4, and cube it. Third step, negative 4 cubed is a negative 64, and we're going to multiply that by 2. Then last, we would subtract 9. The salary of members of the House and Senate in 2008 was $169,000 and had increased by approximately $4,000 per year since then. A. Create a table to help find the expression That stands for the salaries in thousands of dollars for the members of the House and Senate at T years since 2008. Part B, evaluate this expression. Part A, for T equals 6. What does this mean in this situation? We first need to draw a table. Our independent variable is the number of years since 2008. So what we want to do is we want to show the arithmetic so we can develop the expression. So the beginning salary was $169,000 in 2008, and every year beyond 2008 increases about $4,000. So in this case, since we are talking about 2008, that's 0 years, and then we times that by 4, and then we add the beginning salary of $169,000. Now the first year after 2008, 2009, this would be 1 year. We multiply that by 4, and then we add 169. 2 years would be 2 times 4 plus 169. 3 years plus 169. 4 years would be 4 years since 2008. So it would be 2012 would be this. And then for T, that would be T years since 2008, so that would be T times 4 plus 169. And this is our expression. Now normally we put the number first, so the expression would be 4T plus 169. Now if we did part B says let T be equal to 6. Evaluate this, so we would take 6, substitute it into our expression. So that's 4 times 6 plus 169. We would multiply before we add. So that would be equal to 24 plus 169. And that's equal to 193. So what does this mean in the terms of the problem? 6 years after 2008, which would be 2014, the salary for the members of the House and Senate would be about $193,000. This is our last two examples. These were shown on Facebook, and it caused a lot of controversy because a lot of people computed these expressions and got the wrong answer. So sometimes on Facebook it was shown this way, sometimes it was shown on this way, and in this case, of course, this means to divide and this means to divide. So to solve this one, our first step is to do parentheses. So 1 plus 2 is 3, so we have 6 divided by 2 times 3. Now the next step would be going from left to right. We want to divide 6 divided by 2, which is 3, and then we want to multiply it by 3, and the end result is 9. I believe the reason why a lot of people miss this problem in evaluating is they interpreted this expression as this one, and this expression is different than this one. This one we do parentheses first, so this would be 2 times 3. Then our next step, before we can divide, we have to multiply these two, and then that would be equal to, of course, 6, and we have 6 divided by 6, which is equal to 1. This one down here is a lot like this one. Our first step is we want to do parentheses first, so this is 12. Okay, the next step is to divide before we multiply because we're doing it from left to right. 48 divided by 2 is 24, and 24 times 12 is 288. Now again, this expression is not the same as this one, so we're going to get different results. This one, we would have to add the parentheses first. So we get 9 plus 3, which is 12. Now we have to multiply before we divide. So 2 times 12 is 24. 48 divided by 24 is 2. So we get different answers just by having the division line in a different area. Now let's verify this by using the calculator. The first one is 9, just like we got. And the second one, we need parentheses around the whole denominator, and we get 1. For the second problem, 288. For the first one, for the second one, 2. So our answers agree with what the calculator says. Here's the readings and suggested problems. Thanks for watching.